Dear student, now we studied about the characteristics of water turbines, governing of water turbines, selection of water turbines, and choice of size and number of generator units. These are the topics we are studied in these lecture videos. The first topic is characteristics of water turbine. First we know about the characteristics of water turbine, then only we can select the water turbine which is most suitable for hydroelectric power plant based on our applications. The first parameter of characteristic is head, that is the water head. I already told the water turbine can be classified into two types. One is reaction turbine, another one is impulse turbine. The reaction turbine used for operating head up to 500 meter. The belt and turbine are used for above 500 meter. So already we know above 300 meters all the power plant is nothing but a high head power plant. So therefore based on the water head, the reaction turbine is used for 500 meter head, the belt and turbine used for above 500 meter water head. The second characteristic is turbine setting. The belt and turbine is always set 2 meter above the tail raise level. Okay. That is nothing but the low head. Because up to 30 meter, that is the below 30 meter, the water head is there, means that is nothing but the low head power plant. So therefore the belt and turbine usually is set 2 meter above the tail raise. But the Francis turbine is placed at a level very near or below the tail raise level. So based on the above and below or near the tail race, we can select the belt and turbine and then Francis turbine based on the turbine setting. Okay, these are the two characteristics of water turbine. The next characteristics of water turbine is a runaway speed. Okay, the runaway speed is nothing but the maximum speed at which the turbine wheel would run with all gates open. So therefore it is used to allow all possible water inflow under maximum head. Maximum head means what? Above 300 meter water head. The generator coupled to the turbine. We already know the generator coupled to the turbine mechanically, which is must be capable of withstanding full runaway speed of the turbine. So the runaway speed is nothing but the maximum speed. The next characteristic is constant speed curve. Okay, in hydroelectric power plant, the turbines operate at constant speed. The discharge, that is the water discharge, which is the unit is meter cube per second, and the head, water head, vary. Therefore, in the hydroelectric power plant, with the help of speed curve, to keep the speed constant, the turbine output is measured by the brake arrangement. Okay, based on the brake arrangement, we have to adjust the turbine output and we can measure the turbine output. From this range, we can keep the speed constant. The next characteristic is specific speed. It is nothing but a speed of geometrically that would develop 1 metric horsepower under a water head of 1 meter. That is called as a specific speed. How can we calculate it? By using the formula ns equal to n into root of pt divided by h power 1.25. By using this formula, we calculate the specific speed of any water turbine. In this formula, where ns is nothing but the specific rotational speed in metric unit, capital N is nothing but the rotational speed of the turbine, PT is nothing but the output in metric HP, that is horsepower. The capital H represents effective head in meter. Okay, so these are the characteristics. What are the characteristics? Runaway speed, specific speed, constant speed curve, water head. These are the main characteristics of water turbine. From this end, we can select the water turbine for our applications. The next topic is nothing but the governing of water turbine. It is very important topic. So from the schematic diagram of governing of water turbine, we have to study about the operation of the water turbine. Now you see the diagram. The diagram consists of, that means nozzle mechanism, piston rod, servo motor, control valve, floating lever, drive from turbine, and then centrifugal governor, and then restoring linkage. These are the components which are used in the schematic diagram of governing of water turbine. Okay, you see here two arrow mark is there. Left side, that is nothing but the close, the nozzle close operation. This right side means opening one. Okay, so therefore this is the piston rod. Okay, we have to, here we can restoring linkage is there based on the piston rod movement. That means the floating lever moves. Okay, the floating lever is attached to the control valve. The control valve consists of two oil outlet and then one oil inlet. Okay, the servo motor. So the servo motor is controlled by the control valve mechanism. Okay, so the drive from the turbine is attached to the floating lever, which is also attached to the centrifugal governor. These are the governing arrangement of the water turbine. Now we studied about the technical points of the governing of water turbine. Okay, the first one is to have electrical output of constant frequency, it is necessary to maintain the speed of the alternator driven by the turbine. Okay, how to control? Then by the flow of water entering the turbine, by the automatic adjustment of the gate vents in the reaction turbine, nozzle lead in case of impulse turbine. If we are using reaction turbine as a water turbine, how to control the flow of water? By the automatic adjustment of gate vents. Suppose the impulse turbine is used as a water turbines, by the adjustment of nozzle need adjustment, we can control the flow of water entering to the turbine. At the same time, if the load is decreased on the impulse turbine, the governor reduces the water from the power nozzle and the surplus water is diverted with the help of auxiliary relief nozzle. So two nozzle we are using. One is power nozzle, another one is auxiliary relief nozzle, which is used in the impulse turbine whenever the load is decreased. Okay, suppose in case of reaction turbine, there are pressure regulators for discharging the water from the casing to the tail race at the time of drop in load. That means decrease in load. Okay, the speed responsible element, usually the fly ball mechanism or the centrifugal governor. The centrifugal governor is the important part in the governing of water turbine. The control valve is used to supply fluid, that is the inlet and outlet, under pressure to the servo motor in order to activate the turbine control mechanism. Okay, how do we activate the turbine control mechanism? With the help of servo motor. How we can control the servo motor? With the help of control valve. Okay, are you clear? So the use of control valve and the servo motor is used to amplify the small force created by the fly ball, that is the centrifugal governor mechanism. Then another mechanism we are using, that is the restoring mechanism, which is used to hold the servo motor in the fixed position when the turbine output and the load demand are equalized. Because the turbine output as well as the load demand both are equaled. Okay, how we can fix the servo motor mechanism? How can we can servo motor is in the fixed position? With the help of the restoring mechanism. There is the restoring linkage is there, no? That's why. The fluid pressure supply required for action of the servo motor. The centrifugal governor may be belt driven or by small electric motor only. That means the centrifugal that means is connected to the driven by the turbine with the help of belt driven or by small electric motor. So these are the governing of water turbine. Okay, then the next topic is selection of water turbine. How do we select the water turbine for different types of hydroelectric power plant. So the selection of water turbine mainly depends on various parameters is there. The first one is working head, that is the water head. Then available discharge means water discharge in meter cube per second. Then speed of the turbine. Then output. Then nature of the load, whether the load may be base load or peak load. Okay, so we have to consider these factors, then only we have to select the water turbine. The next, the effective head is very very important before we have to select the water turbine. This parameter you have to consider for selection of water turbine, because the turbine is to operate gives the first gauge to the selection of the turbine. Which one is effective head? For high head means is nothing but 500 meter. The water head is 500 meter means which turbine is selected? Belton turbine is suitable for this type of water head. Then suppose the water head, that means 30 meter above, 500 meter below means which turbine is suitable? Francis turbine is employed for this application. Suppose we low head power plant, that means below 70 meter water head, at the time we use propeller turbine as a water turbine. Okay, in some cases that means for 200 meter water head, for this application both Belton and Francis turbine can be used. A runner of higher specific speed, because the specific speed is nothing but the one of the characteristics of the water turbine we already studied in this lecture video. The runner of higher specific speed will generate more power for the same water head. What is the result? In small size of turbo alternator and power house only. So therefore we can use higher specific speed only. Okay, then the last topic is choice of size and number of generating units, because the size is very very important. Generally the size directly proportional to rating. If the rating of the generator increases, definitely the size of the generator also increases, cost increases, the installation cost increases, totally the capital cost increases, as well as the maintenance cost also increases. So therefore the choice of size is the very very important factor. And then the number of generating units also, because all the generator units is synchronized, then we can meet our load demand. Okay, based on the available generator units. Okay, so first the load on the power station is never constant. We already know the load can be varied with respect to time. That means it varies day by, that is the hours of the day, because of our load demand, that is the consumer consume the load. The generating plant should have the capacity to meet our maximum demand. Okay, for example our maximum demand is 100 megawatt, and then our generating capacity by the hydroelectric power plant also 100 megawatts, but the powerhouse having 3 generator means the 3 generator only is used to meet our maximum demand 100 megawatt. Okay, suppose only one unit means one generator is made to meet the maximum demand of the power station, for example 100 megawatt. What happened? The plant will be operating on full load, because maximum demand means that is the full load. Okay, so the full load, that means when the duration of the full load, for short duration only. For short duration, only one unit is made to meet our maximum demand of the power station. What happened? That means it will be running light or even practically on no load for the rest of the day. Because the one unit only is used to meet our maximum demand. So therefore the same unit during no load period, that the unit is for it is rest for the day. Like that we have to use one unit. Suppose in order to maintain the reliability and then continuity of the power supply, what is mean by reliability? We have to maintain the voltage, we have to maintain the frequency and then give security to the power system. Then we are saying our power system is reliability. Continuity of power supply means what? That means the generator units are synchronized, means any one if failed or under service or maintenance, means the other unit is used to meet our demand. So therefore the continuity of power supply is maintained, that is there is no interruption of the power supply. Okay, but the capacity is very very important to meet our load demand. For example, one unit only is used to meet our load demand. Can you possible to maintain the reliability operation of the power plant? Is very difficult, because the reliability of the operation is reduced, because only one unit. Suppose in case this one unit is under maintenance or breakdown, means what? So we can't maintain the continuity of the power supply. Then how can we say our power system is reliability? Automatically the reliability of the operation is reduced. So therefore the generator units are synchronized. That's why the number of generator units is very very important consideration in the hydroelectric power plant. Okay, then the small generating unit can be chosen. I choose the small generating unit to meet our load demand. Okay, so this unit is suitable for the portion of the load curve. Whenever the load, based on the load, okay, it will operate at load giving the maximum efficiency only. If we have to increase the number of that means generator units, number of generator units, what happened? The area required for the installation of generator units, that is the foundation of generator units, is more. Then if number of units increases, definitely the cost of the generator unit also increases. If the number of unit increases, the maintenance also more, definitely the maintenance cost also high. Finally what we get? Less profit in the every year. So therefore so they increase the number of units, that is you can consider. Therefore the compromise to be made in the selection of size and number of generating units. The small number of units, that means to fit them on the load curve only. That means neither single generating unit of large capacity nor large generating unit of smaller size, that means we never use. Okay, so like that we have to choose a choice of size and number of generating units. Dear students, I hope in this lecture video you clearly understand the concept of characteristics of water turbine, selection of water turbine and governing of water turbine. Finally, choice of size and number of generator units used in the hydroelectric power plant. Okay, how the question, this is the level 2 only, that is the understanding level only, that is explain the governing operation of the water turbine in the hydroelectric power plant. So minimum 6 mark, maximum 8 marks only. You draw the diagram and then explain the operation of the governing circuit of the water turbine. Characteristics, totally 5 characteristics is there. You can write down 5 characteristics. So the maximum mark is 6, minimum mark is 4. Characteristics of water turbine in the video examination. The choice and number of generator units, write short notes on choice of size and number of generating units. So this is the maximum 6 mark only. Okay, student, you clearly understand the concept, how the question will come in the VTU examination, how to answer the questions. Thank you students for watching this video.